look today at part 1 of linear relations. And what we're going to discuss in this part 1 is just the general idea of problem solving. Okay? All right, so it's a fairly general idea. Okay? First, as always, I'll show you what the Manitoba curricula expects you to know. Okay? So this is the stuff that every math teacher gets as a guide. It's very general. But basically with this, you're going to be looking for patterns and creating what's called linear equations. Now, we saw that word equation in our previous unit. So I'm going to talk about what that words mean in this context a little bit later on. But we're going to start today with just some general tips. I know the algebra is hard for some of you to digest. So some of this will be a bit preachy. But here's the reality, okay? I have taught math for 16 years. And I have often heard students make statements and heard statements like, I hate math. Why do I have to learn this? I'm never going to use this. Math is super, super hard. In addition to teaching this course and some other math courses, I've taught in our alternative ed program. And I've had students who were taking, for example, math courses for the 4th time, the 5th time, still not being successful. And they will often make statements like this to me, and I'd say, okay, well, wait a minute. We got to refocus here a little bit, okay? I think there's a disconnect. A lot of students don't ever see a practical end to the math they're doing, and in some cases, you might be right. If we look at our last unit, 2x plus 4 equals blah, 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 this doesn't seem like it's ever going to be something you would actually be able to use. Again, not every student, but some students say this. However, the reality of our modern world is most employers and most post-secondary institutions, which includes both universities and community colleges and other types of training institutes, are valuing math more now than ever before. Okay? The math component is big. As a matter of fact, even governments realize this. This is why you see things like on the news about things like math science scores. This is why the government of Manitoba has proposed to change the mandatory graduation age to 18 now, so that if you drop out before that, you will essentially be violating the law. Okay? So this is why they understand that it's going to be harder and harder. I mean, some of you might be trying to get part-time jobs right now and realizing it's a tough market. I had 2 girls in here at lunch, 2 of my grade 12 IB girls, telling me how hard it is to get a part-time job right now. And that's because a lot of the job market now is driven towards students who can maybe do a little bit more. Now, it's not just about math, but the fact is that this is happening. And as teachers, we're frustrated. We recognize that it's an important skill, and yet we're running into kids who I'm trying to sell you, in some cases I always describe myself to other people as, I'm selling a product that nobody wants, okay? As a math teacher, I'm trying to sell them a product, say math is important, and nobody wants this product.
Sell black licorice, basically.
Sure, something like that, okay? I'm trying to sell a chocolate popsicle to a lady in a white dress. How about that, okay? So let's not call it math anymore. Why don't we just call it problem solving? If that's what we call it, then maybe everyone think it's important. Because we all got problems, and we all got to solve them, okay? Now, here's a fancy word. Quantitative, or quantitative, or quantify. Means to put a number to something. I would argue that that's more important now in 2014 than at any point in human history. Mortgages, taxes, figuring out how much you're going to tip someone, figuring out how to use a cell phone, how to use a computer. All of you seem to be on a computer. All of this stuff involves numbers now, more than ever before. Measuring your deck that you're going to build on your house. All this stuff involves numbers in some ways. As a matter of fact, even just simple stuff like who you're going to vote for, which is going to be an issue for some of you in a couple years. You might be voting for a political party that may or may not suit your needs. Okay? Like, let's say you want taxes raised or don't want taxes raised. Who you vote for often is a result of looking at statistics. This party is arguing that Manitoba's doing this, and this party's arguing that Manitoba's doing this. Analyzing those numbers is problem solving, and it is mathematics. It's knowing how to work with that data, okay? But if you think about it while you're here in school, it's still, for a lot of you, it still is hard. Because you think math is math class. And math is math assignments. You gotta go beyond that. The assignments and the class are just the back. I mean, you're not gonna be necessarily doing polynomials 20 years from now. But I guarantee you, you'll be doing math 20 years from now. You'll be doing math 50 years from now. You just won't be doing math class 50 years from now, okay? 8 years ago, you guys were in elementary school. 8 years ago, I bet you weren't arguing with your teacher, and again, I'm not saying you specifically, about how you disliked math back then. I doubt it. It's possible, but I doubt it. I bet you as you were sitting there counting jelly beans in Miss DeLello, Miss, I don't know, whatever your elementary teacher's name is, I would guess it's a female, it's just a good guess, that you probably didn't have that attitude. So somehow it's crept into your mind. Somehow in the last few years, probably, math has become, for some of you, a negative experience. Okay, let's move on. Ty, I'm going to hold your question for a second because I want to get through this for you guys.
Oh, no, it's not a really important.
It's okay.
It's not important.
Okay, so I'm going to argue 3 reasons. 1, getting you ready for jobs. Absolutely, that's one of the reasons why all of you are in high school right now. But it's not the only reason you're in high school right now, okay? But it's absolutely important, okay? 2, everyday living. Like I said, you're not going to be in math class 20 years from now, but 20 years from now, you'll be figuring out how much you're going to pay. You're going to go to Walmart and go, should I pay for this product or that product? And you're going to do some quick math to figure it out. Now, you might argue you already know how to do that kind of math. Okay. The third one, though, is the one that often students don't think of. Math is like brain exercise. It's like working out your brain. So if you think of math as that, like you don't think of phys ed necessarily. You go play dodgeball in phys ed class. You're not thinking, oh, 20 years from now I'm going to be playing dodgeball, so I better learn this skill. You might be. I don't know. Who knows what kind of dodgeballer you are. But you might be just thinking, well, I'm working out. I'm getting fit. I'm getting healthy. Why don't you think of math that way? Math is getting fit and getting healthy, but here, in your brain. You will be a more confident person. You will be a smarter person if you can work out that part of your brain. And math is a way to do it, okay? So that's something to think about. So let's talk about it in terms of solving problems. Okay? Let's not talk math. Let's talk solving problems. All right. So sure, problems come up in math class. Problems even like word problems. But they're going to come up in other places too. You're going to use them in science courses. You're going to use them in history courses. Problems are going to keep coming up. So what I'm going to give you is the WALKS 5-step problem-solving solution. I'm good at giving you guys those step-by-step things. So here it is. 5 steps how to solve a problem. 1, define the problem. 2, find a method for the problem. 3, analyze the method. 4, find the solution. 5, check the solution. It's really simple. Maybe even think of it this way. Define, method, analyze, solution, check. Let's give it a shot. Okay? In step 1, when I'm looking at the problem, and we've already talked about this, think about what the problem's asking, right? What do you know? What do you need to know? Possibly rewrite it in your own words. Even on yesterday's test, I saw some of you come up to me and said, I don't understand the question. I love when students do that. Be clear about what you're looking for, okay? Rewrite it if necessary. Sometimes even just drawing a picture to help you understand. You can't get any further unless you actually know what the problem is. Possibly the most important step is figuring out what the heck it's asking. Step 2, a method. Now here in math class, I'm giving you methods. Like here's a method of solving equations. Here's a method of BEDMOS, right? But this is general problem solving. If I was your language arts teacher, I'd say, here's a method for writing an essay. If I was your history teacher, I'd be like, here's a way to research this question. If I was in power mechanics, the method might be, here's how you fix that carburetor. If this was foods class, I'd go, here's the recipe to bake that cake. The method depends on the problem, but you got to have that method, right? And you may notice down here, one of the suggestions I give you is, if you don't have one, create one, right? My problem, I can't get a date. What's my method? I'm going to invent my own sort of swagger to get that going. Oh, no, this is awful, I know, you're hearing me that. Okay? Sometimes you're taught the methods, sometimes you develop the methods, but the method is there, okay? Sometimes it involves drawing, sometimes it involves building, right? Like this could be Woods class, maybe the method is building. Sometimes it involves writing. Sometimes it just involves talking, okay? A university professor who wrote a book described a technique called the rubber duck technique. And here's what it is. He always would keep a little rubber duck on his desk. And this was actually a professor of computer science. And what he said was when he got into a really hard, like he was trying to write software, and he got to these really hard problems, and he couldn't figure out how to get past it. So this sounds weird, but he would talk to the rubber duck. He'd go, and I can't remember, he had a name for it. And he'd say, and he wrote a book on this, and he said, oh, come on, and they'd say it was Billy. Billy, here's my problem. I can't solve this equation. And he would describe it to the duck. And a lot of people thought he was crazy. But the reality is, sometimes when you explain it out loud to somebody, all of a sudden you figured it out. That act of talking out problems out loud actually can work. It does. Try it. Sometimes, I bet you it's happened to you. Even something simple like you were trying to remember the name of that actor in that movie. Oh, what was the name of that guy? He was in that movie. I can't remember it. And then someone says, what are you talking about? And you go, oh, well, there's this movie. And you know the movie I'm talking about. And then there's a guy. And then all of a sudden you go, oh, yeah, it's this guy. That act of actually speaking out loud often can help you. So I call it rubber ducking it. Pretend you're talking to the invisible rubber duck in front of you. And actually it might help you get through the problem. All right, so now you got a problem, you've got a method. Step 3 is using it, right? So in math class, that's like plugging in the numbers. In history class, that's like doing a rough draft, okay? This is where you spend most of your work time, is actually doing the work, okay? So you figured out what the problem was, you figured out how you're gonna solve it, now you dive in, right? So this is where you like use trial and error, or you fill in answers, or you do a rough draft, or you create variables if it's math, whatever, okay? Moves you to step 4, solution, okay? So now you've got some kind of answer, and a lot of you had that on yesterday's test. So now you look back. Does it match what you said in step 1? For a lot of students, this is a misstep. They'll go, oh, x equals 5. And my question was something else. A lot of you did that on yesterday's test. I got an answer. I'm like, I wasn't asking that question. I'm not sure what's going on there. Now, I still gave points, but it wasn't, the answer didn't match the problem, right? And again, if it's a math problem, there's more specifics there, but always make sure your answer matches your problem. And then the final step is to just check it. It's a simple step. It depends on the complexity of the problem. If I ask you what's 2 plus 2, you probably don't need to check your answer, but you might. But if it's a more complex problem, then the check is even more important, okay? Tynan.
Is linear equations mostly going to be like...
It's coming. No, it's not, okay? Okay. Now, sometimes in the check, you'll be like, and I saw some of you write this on the test, I'm wrong. Like you knew you were wrong in the end. You tried something, but you knew you were wrong. That's good. The fact that you recognize that in the final step is a great way to know that at least your solution might start you back at the beginning again. Now, I know it was a test, so you didn't have time to do that. But in life, right, I was dating the wrong person. Now I go back and fix it again. Why am I doing the dating thing? I don't know. Okay, let's give it a shot. Simple problem. One day, a cab driver picks up 3 couples and takes them to a dance. One girl's dressed in red, one in green, and one in blue. The boys all wore the same different colors, red, green, and blue. The three couples are dancing, and the boy in red dances over with his female partner over to the girl in green and says, "Hey, isn't it weird, Mary? Not one of us is dancing with a partner dressed in the same color. Problem. What is the color of the partner and the girl wearing?" Now, I want to do this using 5 steps. So let's try it. Step 1, define the problem. Well, this one's pretty well defined. If I go back a screen, the color of the partner of the girl in red. So my final answer should say, the partner of the color of the girl in red is wearing this color. Okay, so I've got step 1 pretty well defined. What is the partner of the girl in red wearing? Let's go to step 2. I need some kind of method here, some kind of model. I'm not going to use math. I'm just going to use a chart. I'm going to go, okay, here's all the boys. Pardon me, here's all the girls. Here's all the boys. Here's all the colors. Now I'm just going to kind of logically play trial and error here. But I need to look through the clues. So we know red boy is not dancing with green girl, because that's who he talked to while he was dancing with someone. So I know red boy is not dancing with green girl. That is awful, but oh well. He also said, not one of us is dancing with a partner of the same color. So I can start Xing some of those out. It is lasers, yeah. Now, moving on, I can see something from a pattern here. Red boy must be dancing with blue girl. That's all that's left here, right? I've X'd everybody else. And since blue girl is dancing with red boy, she can't be dancing with green boy because she's dancing with red boy. So green girl must be dancing with blue boy. There's nobody else left. The rest of it starts falling into place. Blue boy is already dancing with somebody. So he can't be dancing with red girl, meaning green boy must be dancing with red girl. Solution appears. Didn't have to use any math, just had to use problem solving and a little bit of logic. Okay? Might be important to you to solve problems in this way, but I've done it in a step-by-step process. So now I'm at step 4. I got my solution. Green boy must be dancing with red girl. Yeah, I found those for you guys last night. I couldn't find a picture of a green boy dancing, but I found a picture of a red girl dancing. I did. All right. Step 5, check. Now, again, this isn't necessarily a math problem, but I'd still go over it looking for errors. Always remember, even math is not flawless. Okay? So, for example, this whole problem was based on an assumption that boys always dance with girls, and that's not always the case, okay? There's no one saying that the 2 girls weren't dancing or the 2 boys weren't dancing, or you weren't dancing with a chicken or a parakeet or whatever. All of that's fine, and as a result, was based on a solution there, okay? All right, let's pull it into this unit now. So now, with math defined, let's talk about what linear relations means, because it's going to come back to algebra a little bit now. The word linear means in a line, right? And relations means how 2 things relate to one another, right? Your relations are your relatives, right? In the context of this math course, what we're talking about are variables that are proportional to one another. In other words, when you change one variable, it will most likely change another. The simplest example of that would be x equals y. So if I change x to 4, y will become 4. Oh, really? It was almost done. Hang on one sec. Just going to pause. We're back in action here. Okay. So, in the terms of math, linear equations means we will be creating, or linear relations, equations that eventually can be graphed as straight lines. We're not going to do graphing today. For those of you that are going to take, for example, pre-cal next year, linear relations expands into much more deeper areas in this way. Okay. So we're going to basically try to express problem solving using equations. So we're going to try to use step 1 and 2 of problem solving to create equations in math, and then we're going to try to solve those equations, like step 3 and 4 and 5. Okay? So this is an example actually from your textbook on this unit. It says, describe the pattern of these shapes using an equation. I think this is actually pretty tricky. But one thing you can notice between figure 1 and figure 2 is the squares have gone up by how many? 3. What's the difference between 2 and 3? How many extra squares do I have now? 3. What about this one? 3. So it's always going up by 3. So that's what I put here. In figure 1, figure 2, figure 3, figure 4, it's always gone up by 3. Okay? So is there a way we can say how many squares are in figure 10? Well, we could just keep doing the math, but if we were to try to work this out a little bit better, what I could do is say, you know what, like here it looks like figure 1, 3, and 2, and etc. I actually came up with an equation for this. The number of shapes, S, or pardon me, the number of squares, is equal to the figure number times 3 minus 2. It works in general for any number of figure. So I can use this now. So for example, with that linear equation, I can figure out for figure 12 that it'll need 34 squares. Okay? I can also use that equation to figure out that if I had 106 squares, I'd be on figure 36. And for this, I just changed the way the algebra worked, which is exactly the stuff we were doing in the last unit. Notice some of the stuff I'm doing there. Adding 2, dividing by 3. This is all stuff we've been doing. This is an actual example in your textbook. So, yeah, it's actually, I think, a fairly challenging one. Okay? Just to wrap up, 5 steps of problem solving, and the definition of linear equation is really all I'm talking about today. The actual thing says look for patterns and develop linear equations. So in other words, problem solving. Okay, and you can actually see some of that in the subnotes here. And that's it. Okay? All right, I am done.